Hello everyone. Are you facing difficulties in balancing chemical equations? Then you have come to the right destination. Welcome to our YouTube channel Wireless Tutor. Dear friends or students, in this video we are going to discuss all of the important methods to balance a chemical equation. Balancing equations is a big problem for all of the students, but they can't ignore this topic because from this topic questions are frequently asked in examinations. So I assure you, after watching this video, the fear of balancing chemical equations will be gone forever. So without wasting any more time, let's get started. Dear students, let us know, why do we need to balance a chemical equation? Why is it necessary to balance a chemical equation? So according to law of conservation of mass, in a chemical reaction, mass can neither be created nor be destroyed. That means the total mass of the reactants must be same as that of the product. So the total number of atoms present in the reactant side must be equal to the total number of atoms present in the product side. If you balance a chemical equation, then it adds so many informations like physical states like solid, liquid, gas or aqueous state. So all these informations are added in the balanced chemical equation. Now look at the example number 1. Magnesium reacts with oxygen to form magnesium oxide. So look at the first equation. In the first equation, Mg plus O2 which gives MgO. In this equation, magnesium and oxygen participate in the chemical reaction. So these are called as the reactants. Magnesium oxide is formed, so this is called product. In this equation, there are two oxygen atoms, but there is a single oxygen atom in the product side. So that this is not a balanced chemical equation. So this is basically called a skeletal equation. Now go to the second equation. In the second equation, we can see that there are two magnesium atoms present in reactant side. There are also same number of magnesium atoms in the product side. This is also true for oxygen. So this is a balanced chemical equation. Now go to the example number 2. Silver chloride breaks down in the presence of sunlight. In the presence of sunlight, form silver and chlorine. Look at the equation number 1. As you can see that though the silver atoms are balanced in both the reactant and product side, but still there is a single chlorine atom in the reactant side, but there are two chlorine atoms in the product side. So this is not a balanced chemical equation. So this is a skeletal equation. Now go to the equation number 2. In the equation number 2, there are two silver atoms in the reactant side. There are also two silver atoms in the product side. So silver is balanced. Now it is the term for chlorine. There are two chlorine atoms in the reactant side. There are also two chlorine atoms in the product side. So this is a balanced chemical equation. Dear students, now this is the time to know the methods behind balancing the chemical equations. The first one is heat and trial method. The second one is algebraic methods. The third one is polyatomic ion method. So by using all these three methods, we will discuss how to balance chemical equations. Now let us know how we can balance a chemical equation by heat and trial method. What do you mean by heat and trial method? Heat and trial method is a way of finding solutions by trying different possibilities until one works. Now move to the equation. Fe plus H2O which gives H2 plus Fe3O4. Now Let us find out how many atoms are present in the reactant side and product side of different elements. There are three different elements: Fe, hydrogen, and oxygen. There are one iron atoms in the reactant side, but there are three iron atoms in the product side. Similarly, there are two hydrogen atoms in the reactant side, and there are also two hydrogen atoms in the product side. But if you see, in the case of oxygen, there is a single oxygen atom in the reactant side, but there are four oxygen atoms in the product side. So in this method, we have to find the element having highest number of atoms and balance that element first. In this equation, we can see that oxygen has highest number of atoms. So we need to balance this equation from Fe3O4. In order to balance Fe3O4, we need to put 4 in the reactant side in front of H2O. Now, as you can see that the number of atoms of oxygen is balanced in both these sides. After balancing that element, we need to balance the remaining elements by heat and trial method. As you can see that the number of hydrogen atoms present in the reactant side is 8. But in the product side, there are only 2 hydrogen atoms. Then we need to put 4 in front of H2. Now hydrogen atoms are balanced in both these sides. Now it is the time for iron. There are 3 iron atoms in the product side, but there is a single iron atom in the reactant side. So we need to put 3 in the reactant side. Now our entire equation is balanced. Now it's time to understand how does the algebraic method stands for balancing the chemical equations. So in this method, we use algebraic variables such as x, y, z in the equation form. After solving those equations, we can balance the chemical equations. Now let us see the chemical equation. Fe plus H2O, which gives Fe3O4 plus H2. In this process, we have to write A, B, C, and D as stoichiometric coefficients before the formulas of the chemical substances. And after equalizing all of these elements or the number of atoms, we can get algebraic equations. Let us equalize iron. On equalizing iron, we can get there is a single iron atom in the reactant side, but there are 3 atoms in the product side. So we can write A is equal to 3. Similarly, on equalizing hydrogen, we can write to B. That means there are 2 hydrogen atoms in the reactant side. So 2B is equal to, there are also 2 hydrogen atoms in the product side. So 2B is equal to 2D. That means B is equal to D. Similarly, on equalizing oxygen, we can write B is equal to how much? 4C. So there are 3 equations. Just put down the value of C because in all of these equations C is the common. So after putting C is equal to 1, we can get A is equal to 3 and B is equal to, just put down here, is equal to 4 and D is equal to also 4 because B is equal to D, so D is equal to 4. And after putting all of these values in the given equation, we can get the balanced chemical equation. Now just put down all of these values in the given equation. The value of A is equal to 3, just put down as 3 in front of Fe. Now put the value of B in front of H2O. Now put the value of C in front of Fe3O4. That is not required because C is equal to 1. Now put the value of D in front of H2. That will be 4H2. So 3Fe plus 4H2O, which gives Fe3O4 plus 4H2O. This is the required balanced chemical equation. Now let us see how does the polyatomic ion method stands for. The way of finding solution in which polyatomic ions are balanced first. Look at the equation H2SO4 plus Ca3PO4 twice, which gives CaSO4 plus H3PO4. This equation looks very difficult, but I assure you that it is the easiest equation to balance. In this method, we need to find the compound having highest number of atoms. Now we can see that Ca3PO4 twice, it is the compound having highest number of atoms. So in order to balance balance the chemical equation, we need to balance from these compounds. So there are two phosphate ions present in the reactant side, but there is a single phosphate ion in the product side. So in order to balance phosphate ions, we need to put 2 in front of H3PO4. Now phosphate is balanced. Now go to hydrogen. There are 2 hydrogen atoms present in the reactant side, but there are 6 hydrogen atoms present in the product side. So in order to balance hydrogen atoms, we need to put 3 in front of H2SO4. Now hydrogen is balanced. Now there are 3 sulfate ions in the reactant side. In order to balance the sulfate ion, we need to put 3 in front of CaSO4. Now sulfate ion is also balanced. Now it's the time for calcium. So calcium, look at the calcium ion. Calcium ion is already balanced. So this is the required balanced equation. Chemical equations. The first equation is that Na2SO4 plus BaCl2, which gives NaCl plus BaSO4. First, look at the polyatomic ions. Sulfate ion is the polyatomic ion, which is already balanced. So now go to the next ion, sodium ion. In order to balance sodium, we need to put 2 in front of NaCl. Now there are 2 chlorine atoms in the product side, which is already balanced in the reactant side. If you go to the case of barium, it is also already balanced. So this is the balanced chemical equation. Now go to the next equation. As you can see that there are 3 oxygen atoms present in the reactant side, which is the highest number of atoms. So it is convenient to balance the chemical equation from this compound. So there are 3 atoms in the reactant side, but there are 2 atoms. Just find out the LCM of this. Then you will get 6. So just multiply KClO3 with 2 and O2 by 3. Oxygen is balanced. Now it is the time for potassium and chlorine. Just write down 2 in front of KCl. It is the balanced chemical equation. Now go to the third equation, NaCl plus F2, which gives NaF plus Cl2. In this equation, you can see that there are 2 fluorine atoms present in the reactant side, and there are also 2 chlorine atoms present in the product side. So you can balance from this side. In order to balance fluorine, just write down 2 in front of NaF, and in order to balance chlorine, just write down 2 in front of NaCl. This is the balanced chemical equation. Now go to the equation number 4, CS4 plus O2, which gives CO2 plus H2O. There are 4 hydrogen atoms present in the reactant side, but there are only 2 hydrogen atoms. In order to balance the hydrogen, just put down 2 in front of H2O. Jauchi. Now hydrogen is balanced. Now it's time to balance oxygen. Oxygen, you can see that oxygen is already balanced, and carbon is also already balanced. Now go to the next equation. You can see that there are 3 carbon atoms and 8 hydrogen atoms. So it is convenient to balance from hydrogen. So in order to balance hydrogen, we need to put 4 in front of H2O. Hydrogen is balanced. Now it's time to balance carbon. So if you need to balance carbon atoms, just put down 3 in front of CO2. Now carbon is balanced. Now look at the number of oxygen atoms. There are 4 oxygen atoms in H2O and there are 6 oxygens in the CO2. So there are almost 10 oxygen atoms in the product side. So just write down 5 O2 in the reactant side. This is the balanced chemical equation for the given equation. For today, thanks for watching our video. If you find this video really helpful, then please like, share and subscribe to our channel. Thank you.